In vitro fertilization, or IVF, is made up of 4 main components: ovarian stimulation, egg retrieval, embryo transfer, and embryo freezing. Understanding each of these components is important, but between egg retrieval and embryo transfer lies a crucial step that patients cannot directly observe: the embryology lab. Important decisions about your eggs and embryos are made in the lab. Not knowing what takes place there can make it seem like a black box. Let's illuminate what happens in the fertility lab by looking inside this box. After egg retrieval, the embryologist identifies the eggs from the surrounding follicular fluid and places them inside a labeled holding dish. The embryologist then moves the eggs into individual wells within a drop dish and looks under a microscope to examine the maturity of the eggs. There are 3 stages of egg maturity: germinal vesicle, metaphase 1, and metaphase 2. The eggs are then placed inside an incubator for 4 to 6 hours before fertilization. Fertilization can occur either by conventional fertilization or intracytoplasmic sperm injection, or ICSI. In conventional fertilization, sperm are added to each well containing an egg, with sperm provided from the intended parent or a sperm donor. Now surrounded by numerous sperm, the eggs are placed back into the incubator in the hope that fertilization will occur. In intracytoplasmic sperm injection, only metaphase 2 eggs are injected. The embryologist injects 1 individual sperm inside each mature egg. The embryologist decides which sperm to insert into the egg based on the sperm's morphology. Sperm come in a variety of shapes and sizes. Normally shaped sperm have a smooth, oval-shaped head and a uniform tail. Any abnormal-looking sperm are not chosen, as they have lower fertilization potential. The eggs and sperm are placed back inside the incubator. The following morning, the eggs are checked for fertilization. Over the next 5 to 6 days, embryo development is periodically assessed. Let's follow the development of the embryos in the lab. On day 1, the nuclei of the egg and sperm are visible. This is known as the pronuclei or zygote stage. The zygote divides into an early embryo with 2 cells. The next day, the embryo divides into 4 to 6 cells. On day 3, the embryo divides into 6 to 10 cells. On day 4, the embryo divides into a ball of cells called a morula. On day 5, a fluid-filled cavity develops within the morula, and the entire mass of cells is now called a blastocyst. The blastocyst consists of the trophectoderm that will form the placenta and an inner cell mass that will form the fetus. This is the usual rate of development, but some embryos take longer to reach the blastocyst stage. Not all embryos become blastocysts. About half of embryos will become blastocysts. Embryo transfer usually takes place on day 5. How are blastocysts selected for embryo transfer? The lab uses the Gardner classification system. Blastocysts are given a number grade, ranging from 1 to 6 based on how expanded the fluid-filled cavity is. This is an indication of its stage of development. In grade 1, the cavity takes up less than half the space of the blastocyst. In grade 2, the cavity takes up more than half the space. In grade 3, the cavity has completely filled the blastocyst. In grade 4, the cavity has increased beyond the original volume of the embryo, causing the zona pellucida, or the shell, to become very thin. In grade 5, the trophectoderm is hatching through the zona pellucida. And in grade 6, the blastocyst has completely hatched from the zona pellucida. Next, the blastocyst is given 2 letter grades, one for the inner cell mass and one for the trophectoderm. For the inner cell mass, grade A means there are many tightly packed cells. Grade B loosely packed cells, and grade C, very few cells. For the trophectoderm, grade A means there are many cells, forming a cohesive layer. Grade B means there are few cells, forming a loose layer. And grade C means there are very large cells, or unevenly distributed cells. The embryologist considers the developmental stage and the grades of the inner cell mass and trophectoderm when selecting a blastocyst for transfer. All developing embryos, however, regardless of grade, have the potential to lead to pregnancy. Patients may elect to have pre-implantation genetic testing, or PGT, to determine if the embryo has the correct number of chromosomes. Using a laser, a sample of cells from the trophectoderm is removed and sent for analysis. This is known as embryo or trophectoderm biopsy. All the embryos that are biopsied are frozen, and the results are used to guide embryo selection for embryo transfer. The embryos are now ready to be transferred. Any blastocysts that are not transferred are frozen for future use. Each one is stored in separate straws. The straws are stored in a cane. The canes are then stored in a large canister, which is stored in a dewar filled with liquid nitrogen. Here, the embryos are kept frozen until they're thawed for future use. Understanding what happens in the fertility lab between egg retrieval and embryo transfer doesn't have to be a black box. It's important to us, in working with you, that you are completely informed at every stage of your fertility journey.